Okay, hello everyone. In a new video, in this one we are going to start a new chapter which is given by chapter 4, mechanical actions, for grade 8 students. And let me start directly with the section number 1, which is given by the force. Then probably in the previous classes or grades you have defined the force as a push or a pull. In this grade 8, we are going to define a force in a more elegant form, which is given by the force as a mechanical action. Exerted by a body on another, and the force is represented by a vector F. So this is the force. Now during the exercises or the activities, we will represent documents in which forces are being acting on bodies, on different bodies, and we will refer to the concept of the force. Now this is just a definition. Now let me move to section number 2, which is the characteristics of a force. And these characteristics usually are referred to as the building. Now we will see why. And let me say here the properties of a force are given by by the properties I mean the characteristics. The properties of a force are given by the point of application, the line of action, the direction, and the magnitude. Now if you refer to these properties, notice that the first letter of each property, this is P, this is L, this is T, and this is M. Okay, so notice that they are given by the building. So we must always list these properties in this order given by the point of application, the line of action, the direction, then the magnitude. Okay, for this reason we call these properties to be them. So let me start by the point of application. So section 2.1, point of application. And let me say it is the point where the force is applied. So let's consider the following example. Suppose that a certain force, a certain mechanical action is represented by the following vector. So you all know what is meant by a vector. So the vector consists of a segment having a tail and a head. So this is the head of the vector, this is the tail of the vector. So let's say that this is the point A, and simply we say the point of application is given by the point A. Okay, so this is it for the point of application. Now we are discussing all four properties of this force. We are discussing the point of application, the line of action, the direction, and the magnitude. Now we are done with the point of application. Let's move to the line of action. So section 2.2, the line of action. So it is the line along which the force is applied. And we have three choices. So let me say choice number one is the vertical. The vertical is given by this direction, by this line of action. The second one is the horizontal. The horizontal is given by this one. And as for the oblique corresponds to the line of action that is not horizontal nor vertical. So this is the oblique. The oblique may be like this or like this or whatever. Okay, any combination that is different than the vertical and the horizontal. So in this case, let's consider also the following example. So suppose that we have a mechanical action exerted by a certain body, and for this we have the following force. So this is the tail of the vector, so this point represents the point of application, and this is the head of the vector. Now we have discussed so far the two properties that are given by the point of application and the line of action. So let's specify these for this given vector. Then the point of application in this case is given by the point B. As for the line of action, notice that this force is not vertical, have a line of action not vertical nor horizontal, so the line of action is simply oblique. And in this case, no justification is required. We just refer to the figure or to the document and we specify the answer or state the answer. Now let's move to 2.3, the direction, and this is very important. Now, why it's important to introduce the direction? First, let me define what is meant by direction. It is the direction along which the force is applied. We have the following choices. So okay, before we list the choices, let me state what is the reason behind introducing the direction. Suppose that somebody stated that we have a force F of an action that is vertical. Okay, so the line of action of this force is vertical. So what is the vertical? Let me say that this is the vertical. Now, but this is not sufficient in order to represent the force, because notice that I have stress on the fact that the force has a head and a tail. So somebody can say that this is the point A, which is the tail, and this is the arrow of the vector. For the same line of action, we can say, for example, this is the head and this is the tail. So in this case, the head and the tail are not specified for this vector. So in order to specify the head and the tail, we need to specify the direction. So for this simple reason, this direction will be downward, the previous direction will be upward, so simply the direction will be determined by the arrow on the head of the vector. Okay? And let me list the different choices that we have, and this is done by referring to this symbol. So this symbol consists of several vectors having the same point of application. If the vector is pointing toward this direction is said to be the right. If it's pointing to this direction is said to be the left. And we know that this direction is said to be upward. This direction is said to be upward to the right. This direction is said to be upward to the left. This direction opposite to upward, which is downward. Then we start by this and we move to the right, so this is given by downward to the right. And this is given by downward to the left. Okay, so these are the different directions corresponding for the action of a force, which is represented by a vector. Now let's consider the following example. So now suppose we have a force, a mechanical action which is represented by this force. Now suppose that this is the head of the vector, this is the force F, having a point of application C. So now, so far we have discussed 3 properties out of 4 and they are given by P, L and D. So let's state them for the final example, for this example. So the point of application is given by the tail, which is the point C. The line of action, so recall that this is the vertical, this is the horizontal, this is completely horizontal. And the direction is determined from the head of the vector, which is to the right. Now the final section, which is given by 2 points for the magnitude. So what do we mean by the magnitude? So simply the magnitude is just to represent the strength of the force, and let me say the magnitude of the force gives us information of how much strong the force is. The SI unit of the force is measured. Sorry, the SI unit of the force is in newtons, and its symbol is M. So the SI unit of the force is given by newtons, and now let me say what are the different instruments, or what is the instrument that is used to measure the magnitude of the force. Always whenever we introduce a quantity in physics, we need to specify an instrument that allows us to measure this quantity. And let me say the magnitude of the force is measured using a spring balance which is given by the dynamometer, or they say dynamometer, it's the same. Or using other methods, as we shall see later. See later. Therefore, now let's consider the following examples. So let me say example number 1. So suppose that we have the following force. So this is the point G, and this is the force W acting at the point G vertically downward, and of magnitude 35 newtons. So here the question is just list the properties of all given forces. So what are the properties of the vector W? Simply the point of application is given by G. The line of action, so this is the point of application which is given by G. The line of action is vertical. The direction is determined from the head of the vector, which is downward. And as for the magnitude is indicated in this case on the vector itself, which is given by 35 newtons. Now let's move to the other example, which is example number 2. So let's consider the following force having a point of application A. The name of this force is given by F, and its magnitude is given by 30 newtons. So what are the properties of this force? Notice that here I have listed these properties in the following order, in the order of Pildim. So if we specify the direction before the line of action, so this is considered wrong. Now let me say that the point of application is given by A. A line of action, so the point of application is given by A, and notice that I'm listing these properties according to the Pildim order. Now the line of action, this is the horizontal. As for the direction, notice that the direction of this vector is determined from the head. The head is pointing to the right. And as for the magnitude, notice that the magnitude of this vector is indicated here, which is given by 30 newtons. Recall that I'm listing these characteristics, the properties, in the Pildim order. So that's it for me in this video, guys. In the next part, we will check how to represent a force using a scale, and we'll solve exercises on this chapter.